Now we will look into the chapter 10.2 of NCERT Class 10 book of chapter 10. So this is chapter 10, which is also related to circles. So here we will take all the questions one by one. So let's take question number 1. There are 2-3 questions which are of multiple choice, but for each and every question to tackle, we need to make some diagrams and do some thinking. So let us take it one by one. And if you don't have a NCERT book in the physical form, you can always go to the ncert.nic.in, and then you can download it freely from there. So just download the class 10 mathematics book, go to chapter 10, you will find that in the PDF. And now we are taking up the exercise 10.2, which is related to circles. So here the first question, I will just read out the question. From a point Q, the length of the tangent to the circle is 24. So whenever you come across any such question, always try to make a diagram. So it's telling that point Q. So let us assume that this is point Q. I think we need to just make it, yeah, now it looks like a tangent, and we will name this point as point Q, which is a external point to the circle, and this is the circle with center. The length of the tangent to a circle is 24. So this is 24 centimeter. And the distance of Q from the center is 25. So this, let us assume that the center is represented by O. So this is 25 centimeter. The radius of the circle is, now it is asking the radius of the circle. It means it's asking this length. Let this point be called P. So OP will be the radius. So this is what we need to point out. So I have read the question, made the diagram, and now we are trying to solve this problem. So this is very simple problem. Any tangent, it's given that QP is a tangent, so any tangent is perpendicular to the radius. This is the theorem which we have already proven and read about. So this triangle PQO will be a right angle triangle, and we can apply the Pythagoras theorem. So here OP square plus QP square will be equal to OQ square, because OQ is the hypotenuse. 25 square, QP is 24 squared, which is already given, and OP we don't know. This is what we need to find out. So here what we will do, we will transfer this plus 24 squared on this side, just so that we don't have to do lots of calculations. It's a little bit smart way. And here you can see this is a square minus b square. So let us put it this way. The formula is a plus b into a minus b. So a minus b is very simple, 1. A plus b is 49, which is 7 square. So OP will be equal to 7 centimeter, and that is the answer. Let us go to question number 2. Again, it is referring to figure 10.11, which we will first make here so that we can yeah, so this is a circle, and then there are two tangents, TP and TQ. So let us assume that one of the tangent is this one, and then another tangent from the same point TP is this one. So here this is T, this is P, and this is Q. And let this be the center O of the circle. It's telling that TP and TQ are two tangents which we have made with a center O of the circle, so that angle POQ is 110 degree. It's given. Angle POQ, let us make a POQ, which is 110 degree. Then it's asking what will be PTQ. So here that is the question. Now we will try to get the answer. So PTQ is this angle, isn't it? This is what is to be found. Looking at this diagram, it was already given that PT is tangent, TQ is also tangent, and tangent always makes 90 degree from the point of contact to the radius. If we draw a line from the center of the circle to the point of contact, it will be radius and it will be 90 degree if it is a tangent, and it's already given that PT is the tangent. Similarly here TQ is also tangent, so this will also be 90 degree. So if we consider this quadrilateral PTQO, all the angles together will be 360 degree, isn't it? And then we already know that this angle and this angle, these are 90 degree. So 90 degree plus 90 degree angle, these two angles will be 180 degree. So what is left? These two angles should also be 180 degree, so that all angles put together should be 360 degree. Let us write that in the form of equation. So 90 degree plus 90 degree plus 110 degree plus angle PTQ should be equal to 360 degree, isn't it? Because it is a all these four angles are from a quadrilateral. So here you can add all these things. 90 plus 100, 110 is 200. So 200 plus 90 is 290. So we can write down, or 290 degree plus PTQ will be equal to 360 degree. So now we can just easily find that PTQ should be equal to 360 degree minus 290 degree. That gives us 70 degree. So that is the answer. The answer is the B here. Let us take up another question. Question number 3. So in question number 3, it says that if a tangents PA and PB from a point P to a circle with center O. Let us first of all make a circle, and then probably it is talking about uh, external point P, probably. So let us make the similar figures here. I think okay, let me just make it as a tangent, and maybe from here also we have to make it in the form of tangent. It needs a little bit of adjustment, no problem. So now what we can say that this is external point P, which it is talking about. And then from P, there are 2 points of contact. This is A, and then this is B on this circle. And obviously, let us assume that this is center O. And then it says, this PA and PB are inclined at each other at 80 degree. So this PA and PB are making 80 degree angle. Then we need to find out angle POA. What will be the value of POA? This is also a very straightforward question. We already know that these two are the tangents to the circle. So this will be 90 degree, this will be 90 degree. In that case, these two angles together should be 180 degree. It is just by the second question which we have seen, we have deducted from it, and there is a theorem also, a general property of quadrilateral. So that makes our life little easier. Then we can very well say that angle POA is equal to 180 degree minus 80 degree. That means 100 degree. Okay, POA. Angle POA. Yeah, sorry, there was one mistake which we did. Angle POA, actually I was wrong here. It is not asking this whole angle, which happened to be angle AOB. It is just asking half of that. It's just asking half of that angle. So this POA, 2 times POA will be equal to 100 degree. Do you know why? Because this is 80 degree and angle AOB should be 100 degree. So that both together will be 180 degree. So half of that, which happened to be POA, which we need to find out, should be 100 divided by 2. That is 50 degree. So it's very important to make the diagram correct and understand what the problem is asking for, or maybe the question is asking for. We just got confused a little bit between angle AOB and POA, but that's okay. Let us go forward and tackle the fourth question. The fourth question, I will again read out the question. There is a kind of proving prove that the tangents drawn at the ends of a diameter of a circle are parallel. So this is a kind of statement. But let us investigate it a little bit. We have made a circle, and let me just try to make two pair of tangents. Now I have made two pair of tangents, one tangent and then another tangent, and these two tangents are drawn on the two diametrically opposite point of the circle. And what is diametrically opposite point? You know, every circle has a center, and then if we draw a straight line going through the center, it will cut straight line into the circle at 2 points. So here, this is the one point, this is another point, and this will be a kind of straight line, and this will be diameter. So it is asking the question, according to the question, if we draw two tangents on these 2 points, they will be parallel. So we can start deducting it as, and let us also call it tangent PQ and maybe tangent TS. So tangent PQ will make angle of 90 degree, isn't it? Why? Because this is radius, isn't it? And the same radius extends till this point, and where the second tangent is drawn, and this will also be 90 degree because all tangents make 90 degree angle or perpendicular to the radius, or you can say also diameter. So as these two angles are 90 degree, then by the previous theorems, these two tangents will also be parallel. So it's as simple as that. Let us take up the next question. Question 5. Question 5 says, prove that, and this is the statement of question, prove that the perpendicular at the point of contact. Let me draw a circle, and then we can, it's telling prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So this is again a very simple question, and I think no need to prove it. We already know it by reversing the theorem 10.2 or 10.1 which we have read earlier. So, but let us just do that very slowly so that we understand everything. Prove that the perpendicular at the point of contact. Let us think that this is make a point of contact. Perpendicular at the point of contact to the tangent to the circle. So let us make a tangent. This is the tangent and this is the point of contact. I think I have not made maybe this looks more correct. The perpendicular at the point of contact. So to the tangent to a circle passes through the center. So we have made a perpendicular from the point of contact, and then we need to prove that it will pass through a center of the circle. This is what we already read in the theorem before, so it's very obvious, no need to think about it. It will pass through the center, because if it is 90-degree, then this will be the radius, and if this will be the radius, radius always passes through the center of the circle. So let us go further and solve the next question. The next question says the length of a tangent from a point A at distance 5 centimeter from the center of the circle. Let us again make a circle first. The length of a tangent from a point A. Okay, so it's talking about an external point A. Let it be like this, maybe point A. Length of a tangent from a point A at a distance 5 centimeter from the center of the circle. Okay, this is center of the circle, and probably this is 5 centimeter, isn't it? We will see later if we are correct, we have drawn correct. Maybe if we have understood incorrectly, which could happen sometime in the examination, we will just try, we will correct it. Length of a tangent from a point A at a distance 5 centimeter from the center of the circle. Yes, I think this is what. So point A is 5 centimeter distant from the circle, center of the circle, is 4 centimeter. So you see, sometimes, let me just draw it again, because this is not a very good. Sometimes this statements are a little bit complicated. So what they are, this question is telling that this is 4 centimeter. Let this point be P. So it is telling that external point A is 5 centimeter from the center. That is one thing. And the length of the tangent from A, this is length of the tangent, this is length of the tangent, is 4 centimeter. Then it is asking find the radius of the circle. Radius of the circle will be this one, this one. You can very well apply Pythagoras theorem. OP squared, which is radius of the circle, plus 4 square is equal to hypotenuse, that is 5 square. It's already given. So radius of the circle will be equal to 5 square minus 4 square, which is 5 minus 4, just to avoid all the calculations which we might have to do. 1 multiplied by 9, which is 3 into 3. So OP will be equal to 3 centimeter. So here in this question, you just have to understand the statement little bit. It's a big sentence, so sometimes students may miss out on the complicated sentences. So always try to spend some time and try to understand it in bits and pieces, then it will be okay. The next question, question number 7, looks like we have to make a concentric circle. First of all, I will read it. Two concentric circles are of radius 5 centimeter and 3 centimeter. Okay, without going any further, let us make two concentric circles. Yeah, so it's not perfect, but let us assume that this is what it is. Find the length of the chord of the larger circle which touches the smaller circle. Okay. So the chord it is talking about is of the larger circle, on the larger circle. So like this. I think it's a little difficult to okay, so it's almost okay. Let us assume that this is the chord on the larger circle which touches the smaller circle, and then as they are concentric circle, the radius, this radius is 3 centimeter, and this radius for the larger circle is 5 centimeter. That's okay. Then what it is telling us to ask, to find the length of the chord of the larger circle which touches. So one thing, we know that it touches the smaller circle. Where it touches here. And the two other points where it touches the bigger circle is here. Okay. So that is the question, and we let us just name it O, P, Q, T, for example. So we have made a diagram, and let us see what need to be found out. So we actually have to find out length of TQ, or length of the chord. So for that, we will do one construction. We can do one construction. Let us combine these points T and O, and that will be 5 centimeter, isn't it? Because it is coming from the center of the circle and cutting the larger circle at one point. So this is 5 centimeter. And what is this one? How much is this? So OT is 5 centimeter, OP is 3 centimeter because it is radius of the smaller circle. So this is 3 centimeter, this is 5 centimeter. And then as this chord is a tangent to the smaller circle, then that will be 90 degree. We have already read that. So, and then triangle OTP will be right angle triangle. Okay, and then we can very well apply Pythagoras theorem. So this 5 centimeter will be hypotenuse. It will be equal to 3 square plus TP square. So 25 9 plus TP square, that will give TP square is equal to 16. So TP will be 4 or 4 centimeter. So TP will be 4 centimeter. So what will be TQ? TQ will nothing but 2 times 4 centimeter, isn't it? This is 4 centimeter, and similarly this will also be 4 centimeter. So 8 centimeter will be the answer. Okay, let us go to the next question. Question number 8. I will again try to just read the question first. Yeah, this looks like a little bit complicated question, but let us try to take it. Again, it's talking about a circle, and then the question reads like this: a quadrilateral ABCD is drawn to circumscribe a circle. Okay, so first of all, there's a quadrilateral, and that quadrilateral, what does it do? It circumscribes the circle. So I think we need to make it a little bit yeah, a little bit difficult to make it, but let us assume that this quadrilateral, let me just name it here first, because it's telling A B C D. Okay, this is A, this is B, C, D. So ABCD is quadrilateral which circumscribes. Circumscribe means a circle is just within it and which is touching its sides. So all these sides of the quadrilateral is actually tangent to the circle which it circumscribes. Then then it's telling prove that AB plus CD is equal to AD plus BC. So here AB, this is AB, this is the side, and plus CD. So opposite sides put together is equal to AD plus BC. This is what it is talking about, isn't it? So now how we can do that? Is there any way you think it could be done by applying the maybe the theorems of tangent to the circle? Yeah, we can do that. Let us name the points where it touches the circle. So point of contact to the circle. Maybe let us T, Q, P, Z, for example. By this theorem of tangent, we know that, for example, AT and AZ should have the same length. Similarly, TB and BQ should have the same length. It will be different than AT, but TB and BQ should be the same. Similarly, QC and PC will be the same. Why? Because they are tangent from this common point C. Okay. And similarly, length of DP will be equal to length of DZ because it's tangent from the common point D. So let us name all those things so that we can try to simplify. One thing is certain that, okay, so let us do the nomenclature in little bit different way. Let us say that this length AT is equal to J. Then AZ will also be J, isn't it? Let us assume that length of TB is K. Then BQ will also be K. Then let us assume that QC will be L. Then CP will also be L. And then let us assume that DP is M. Then ZD will also be M, isn't it? So now it's a quadrilateral, and we need to prove actually this one. So let us try to break down AB into what we have assumed, a kind of according to the tangents law. So this AB is J plus K, isn't it? J plus K. And what is CD in that fashion? CD is L plus M. And then what is AD and BC? So let us see AD. What is AD? J plus M, isn't it? And then what is BC? BC is K plus L. Okay. So this AB plus CD is this one. And this AD plus BC is this one. And then you can see that these two things are same because you see there is one J, here one J, here K, L, M, M. So we can prove that this is equal to this. So this is how we will do this question. The next question, question number 9. Again, there is a little bit complicated figure 10.13, and it says that in figure 10.13, xy and x dash y dash are two parallel tangents to a circle with center O. Let us make this figure. So this is a circle, and then these are the two tangents. Let us make it like tangent. Now this looks like a tangent. Yeah, this also looks like a tangent. The center is O, and this is x y tangent, and this is x dash y dash line, which is a tangent, and center is O. And then it says another tangent AB with point of contact C intersecting xy and x dash y dash. Okay, so again let us make another tangent. I think I just forgot to just, so let me just draw it again as a straight line. So this is a tangent AB. AB is a straight line which is also tangent, which touches the circle at point C. This is what it is. Point of contact is C for this tangent AB. Prove that AOB is 90 degree. Okay, so now we have to prove that angle AOB. Let me just draw AOB. We have to prove that this is 90 degree. Yes, so now how we can, so this is the question, how we can solve it. We need to think about one way of solving it could be utilizing the fact that these two tangents are parallel. But what we can deduce out of it, if these two tangents are parallel parallel, and then AB is the line which is cutting that tangent, then we know that this angle, sum of these two angles will be 180 degree. Maybe it looks a little bit I'm not sure whether you understand it or not, but this is what it is. If there are two parallel lines which are cut by a third line, then these two angles put together are 180 degree, and these two angles are same. So we can very well prove it. That is not a question, but this is what it is. So we will utilize that fact to solve the problem. As we say or know that angle XAC plus angle CBX dash is 180 degree, which we just saw, because these two lines which are parallel to each other is cut by the third line. But XAC, let us investigate a little bit more into detail. We can also draw a line here, and we know from the previous theorems that these two triangles are congruent. Let me also, these two triangles, let me just make it again. Triangle XA, no, this triangle I am talking about, this triangle and this triangle is congruent. So these two angles will be the same, and these two angles put together is XAC, isn't it? It's XAC. So this angle will be how much? This angle will be XAC divided by 2, because it is half of this one. And then similarly, CBX dash divided by 2 will be angle OBC, isn't it? But here Why? Because again we can just draw a circle here, call it point T, and here call it Q. Okay, so angle OCB will be congruent to no, triangle OCB will be congruent to triangle OTB. So these two angles will also be the same. Okay, and this is what we have written. So this will be nothing but CBX CBX dash divided by 2, isn't it? Because this is CBX, so this is half of that. But if we halve both of it, this one and this one, but we know that together they are 180 degree, so we can also say that this is 180 degree divided by 2, isn't it? So we have already proven that these two angles are 90 degree. So if these two angles are 90 degree, then this also has to be 90 degree. Angle AOB also has to be 90 degree. Why? Because in this triangle, let me use another color. In this triangle, all the angles put together should be 180 degree, and we have already proved that this angle and this angle is 90 degree. So this also has to be 90 degree. So we proved that angle AOB will be 90 degree. Little bit complicated problem, but I think maybe you can understand that.